When we think about equivalent ratios, we can think of them as a multiplication table as well. When we're making equivalent ratios, you are multiplying or dividing each of the terms by the same number. So if I'm looking at this multiplication table, I just go 3 by 4 or 1 by 4 real quick. If I do 1 times 1, I get 1. 1 times 2, I get 2. 2 times 2, I get 4. So here's just a little mini multiplication table. There are ratios on this multiplication table. So let's look at a ratio of 2 to 3. So if I go 2 to 3, and I'm just looking at my 2 to 3 ratios, okay? If I take 2 and double it, I can make 4. And if I take 3 and double it, I can make 6. So over here, I can say 2 to 3 is equal to 4 to 6 because both of them have been doubled. Okay, if I look over here, 2 to 3 is also equivalent to 6 to 9 because 2 times 3 is 6 and 3 times 3 is 9. So I can also write 2 to 3 is equivalent to 6 to 9. So 2 times 3, 3 times 9. All right, I can also pick another pair in my multiplication table and it would still work as well. Let's look at 3 to 4. So 3 to 4 is equivalent to 6 to 8. Because if I double the 3, I make 6. And if I double the 4, I get 8. So both of my terms in my ratio have been doubled each time. Okay, I can also go 3 to 12 is times 4, as 4 times 4 is 16. So those are equivalent ratios as well. Again, I can put them in fraction form and make them fractions. 3 times 4, 4 times 4, and make those equivalent. So when we think of equivalent ratios, we need to think about what's multiplying or what's dividing in order to make that equivalent. Okay. I can also do numbers that are not next to each other. So let's say I do 1 to 3. So if I just look at my ones row and my threes row, it would be the same thing. 1 to 3 is equivalent to 2 to 6. And 2 to 6 is equivalent to 3 to 9 because they're in the same row and they're all going to be equivalent to 1/3. So if I start writing this down, 1 to 3 is equivalent to 2 to 6, which is equivalent to 3 to 9, which is equivalent to 4 to 12. So when I'm looking at these, 1 is being doubled, 1 is being tripled, 1 is being quadrupled, 3 is being doubled, tripled, quadrupled. So all of these are equivalent to each other because they're all equal to 1 to 3. So let's look at this for a second. I can say 2 to 6 is equivalent to 3 to 9. Now, some of us looking at this think, well, I don't know what 2 times 3 is, 2 times what is to make 3, and what 6 times what is to make 9. But both of these ratios in simplest form is 1 to 3. So 2 to 6 is 1 over 3, and 3 to 9 is also 1 to 3. And those are equivalent fractions because they are the same form. Okay, so let's practice this a little bit more. All right, so now we're seeing if 18 to 21 is equivalent to 30 to 35. Again, I can write this in fraction form, and some of us will be thinking to ourselves, I have no idea how many 18s go into 30. So there are 3 ways to figure out if you have equivalent ratios. The first way is to put them into lowest form. So if I put 18 to 21 and I put it in simplest form, I know that 3 goes into 18 and 21. So 18 divided by 3 is 6, and 21 divided by 3 is 7. Okay? What about 30 and 35? I know, since I end in a 0 and a 5, that 5 goes into both of these. So 30 divided by 5 is 6, and 35 divided by 5 is 7. They both give me the same fraction in simplest form, so these two ratios are equivalent. I can also change them to decimals. We've talked about how fractions can become decimals by doing division. Again, I can make this ratio a fraction, so 18 over 21. So in my calculator, I would do 18 divided by 21, and I would get a decimal like this in my calculator. And same with 30 over 35. It becomes 30 divided by 35, and it would give me the same decimal in my calculator. So since I have the same decimal, that means they're equivalent ratios. The last way is to make a common denominator, like when we added and subtracted fractions in 4th and 5th grade. So if I have 18 over 21, and I want to see if it's equal to 30 over 35, I would need to find a common denominator, which is my least common multiple. So I can make out my multiples of 21 and 35 to see what my least common multiple is, or I can use the slide method to figure that out. I already went ahead and did it. It is 105. Okay, so 21 times 5 is 105, so 18 times 5 is 90. Okay, 35 times 3 gives me 105, so 30 times 3 is 90, and they equal the same fraction. So those are the three ways that I can see if they're equivalent ratios. So since my first way was putting it in simplest form, it was 6/7. They were both 6/7, that means they're both equivalent. I divided both of them. They both equaled a long decimal that was the same decimal. And then the third way was to make common denominators and see if the numerators were the same. Okay, let's look at another example. All right, what about 8 to 9 and 9 to 10? A lot of us would be looking at this going, well, I added 1 to 8 to make 9, and I added not 1 to 9 to make 10, so they must be equal. But remember, when we're finding equivalent ratios, we're only using multiplication and division. So the first way is to put them in fraction form and put them in simplest form. So 8 over 9 is already in simplest form because there are no common factors of 8 or 9. Hi, Sable. And 9 over 10 is already in simplest form as well. So these two fractions are not equal because they, in simplest form, they don't have the same numbers as our numerator and our denominator. I can also divide to prove that they are not equivalent. 8/9 becomes 8 divided by 9, which is 0.8 repeating. And 9/10 is 9 divided by 10, which is 9/10. So my decimal forms are not equivalent, so that means that these two ratios are not equivalent. And the last way I can check is to put them with a common denominator. So if I do 8/9 is equal to 9/10, my lowest common multiple for my denominators is going to be 90. So 9 times 10, so 8 times 10. 10 times 9, so 9 times 9. So those are not equal. So those are the three ways to prove if two ratios are equivalent to each other. Put them in common form, put them in lowest form, or change them decimals to see if they're equivalent. And that is how I can tell with equivalent ratios.